All right, I'm going to continue on with this series about long-range rifle shooting, and today I'm going to talk about scopes. I'm going to try to keep from getting too deep in the weeds about the details of the scope itself and talk a little more about what I think are some good features to look for and how to kind of maximize what you're getting for your dollar when you buy a scope for your long-range rifle. So hopefully this will help you make some good decisions and get you what you need to get started. So the first thing I want to talk about is budget, because a lot of people have a question about how much they should spend on a scope and whether cheap scopes are going to get the job done or if they're wasting their money. So generally I'd say if you don't have a ton of money to work with, don't let that discourage you from getting started. There's a lot of good scopes on the market now in the $400 to $600, $800 range that while they're not going to be quite as good as the higher end scopes, they do offer a lot more bang for the buck than you used to be able to get, and they will be a lot closer in terms of performance. If you can afford more, then sure, go ahead and get a more expensive scope. I'd say, figure out what your budget is as far as what you can afford in the scope, and then just try to find the best thing that suits your needs in long-range shooting in that price range. Okay, mils versus MOA. Right off the bat, I want to make a recommendation that if you're getting into this and you haven't bought a scope yet, get a mil scope. Milliradian is going to be a lot more common in the long-range shooting community, especially if you get involved in competition or you start taking some training. Most of the people you talk to are going to have mil scopes. So when you start exchanging data or talking about wind holds, things like that, it's going to be a lot easier if you're speaking the same language. There are some problems with getting MOA scopes that you usually don't find in mil scopes. So when you get a mil scope, you're going to have turrets that are set up usually 1/10 of a mil per click. And then you will have, whole numbers. So you have 1 mil, 2 mil, etc., and have like 10 mils per revolution on a lot of these things. And the reticle is going to be graduated at the same scale. So you'll have a reticle with 1/2 mil hash marks or 2/10 of a mil hash marks preferably. And those measurements in the reticle are going to align with the measurements on the turret. When you start talking about MOA, one MOA is 1.047 inches at 100 yards. And what a lot of manufacturers do is they put 1/4 inch clicks on their scopes. So when you dial up one MOA at 100 yards, it's an inch instead of 1.047. And now that might not seem like much when you're talking about an MOA at 100 yards, but when you start talking about an MOA at 1,000 yards and then having to dial up 30 MOA on your scope for that drop at 1,000 yards, now you're compounding the difference. And it could come out to be like 20 inches of difference at that distance. So if you have a ballistic calculator that's giving you a true MOA come up for your elevation, and you're adjusting in 1/4 inch clicks instead of true MOA clicks, you're going to have some discrepancies there that are going to cause you problems. Also, the reticles in an MOA scope are usually designed around a true MOA. So the measurements you're seeing in your reticle as you use it for, holding wind, things like that, or even ranging a target, they're going to be different than the adjustments on your turret. So generally speaking, I'd say avoid MOA scopes for this type of shooting and just go straight into mils. I think it's going to be a lot easier to work with in the long run. As far as maximum magnification range goes, a lot of people tend to overestimate what you need for long-range shooting. You can get along just fine with a 20 power scope or a 25 power scope. You really don't need to get up into that 37 and 40 and up range. When I'm shooting long range, I generally don't use the maximum magnification on my scope very often. I might shoot at 14 to 18 power on a 20 power scope at the most, and even 18 is kind of pushing it. Especially when you're talking about lower priced optics. The best performance of your scope is usually going to be, 20, 30% back from maximum magnification. So if you have a 25 power scope, maybe 20, 21 power is kind of the end of where it still really looks good through the glass. And as you get beyond that, you get a lot more darkening. You start losing the light and you start losing some of the optical clarity. So don't worry about getting a gigantic magnification range just because you're going to shoot 1,000, 1,200, 1,500 yards. You most likely won't use it anyway once you get behind the gun and you start seeing how much you're limited in field of view by having your scope cranked up to maximum magnification all the time. So as far as first focal plane versus second focal plane reticles go, for this type of shooting, you're going to want to go with a first focal plane reticle. Second focal plane reticles are going to be a constant size to your eye as the magnification range changes. So you'll dial back the magnification range and the target will shrink in appearance inside the scope, but the reticle will stay the same size. And what that does is it throws off the accuracy of your measurements. So the graduations on your reticle, if you're set up for half mil or 0.2 of a mil increments, they're only going to be accurate at your maximum magnification. So as the target shrinks, the value of those hash marks in the reticle are going to change. And if you stick with first focal plane, the relationship between the reticle and the target is going to stay the same. So the reticle will grow as you increase the magnification and your target grows in the image in the scope. So that's going to be the best way to go. That way, no matter what setting you end up using as you're shooting long range, your wind holes are going to be accurate. All right, reticle selection. There's generally going to be two major kinds of reticles that you're going to come across when you start looking at scopes for this type of shooting. And that's going to be a standard crosshair type reticle with graduations for windage and elevation, and the Christmas tree type reticle, where you have, below the main horizontal line, you have an increasing set of lines that give you elevation and windage holds. So you can use pure holds, when you're compensating for range and windage on a target, instead of dialing for elevation and then just holding wind. So that's generally going to look something like this, where you have a standard crosshair with graduations versus a Christmas tree type reticle. And what you choose there is really going to be more personal preference than anything. Probably most shooters that are competing today or spending a lot of time doing long range shooting are going to be dialing their elevation for almost all their shots and just holding windage on their main crosshair line. There's an advantage to having the tree reticles, which it can be speed in engagement if you're wanting to get on target fast and not take the time to dial your reticle, and you don't need a really refined adjustment like you would get out of dialing the turret. But the downside of it is, as the reticle gets more cluttered in that Christmas tree area, it's going to obscure your ability to spot your misses. So if you hit a little low, left, something like that, you're hitting in the dirt, the Christmas tree part may obscure that to some amount and make it harder for you to spot those misses so you can make corrections. So generally I'd recommend, if you do look at a Christmas tree type reticle, look at one that is a little more open, with maybe gaps in the lines or small dots for your windage corrections, so it won't obscure your view as much. As you start talking about the really complex reticles with a lot of extra marks, wind dots, things like that, the tremor reticles, those can be useful for certain types of shooting, but they will also obscure your vision a lot below the main horizontal crosshair line. So it's just something to keep in mind when you're looking at these things. You don't necessarily need to go out and buy the most complex reticle you can find. It may be more of a detriment than anything. The best thing to do is probably try to find a sporting goods store or a gun store around that has a large selection of scopes that you can look at with different types of reticles in them, and then just go firsthand, look through the scopes, look at the reticles, see what kind of catches your eye as far as something you want to work with when you're shooting, and see if you don't think that some of these reticles are maybe a little too busy to be useful for this type of shooting and would obscure your view. As far as the resolution of the measurements on the reticle goes, this scope has half mil increments, and this scope has 0.2 of a mil increments, and this scope has 1/4 mil increments on the reticle. And I would say generally you're better off going with something that has at least 1/4 mil increments or 0.2 of a mil for your holds. I'm able to work with this pretty well because I've been using it for a long time, but it does leave a little bit to be desired in the accuracy of wind holds because it's only got half mil increments in the hash marks. So if you have something with 0.2 of a mil, it's pretty easy to count in twos or in quarters. So it's not going to be something where you're going to get lost in the reticle very easy, but it is going to give you the ability to refine your wind holds to a finer degree as the targets get longer distance and smaller, more challenging. All right, turrets. When you get into this type of shooting, you're going to be spending a lot of time dialing your turrets for elevation to make your adjustments, as you go out in range. So it's a good idea to get something that is going to work good for you as far as the size of the turret and your ability to read the hash marks on the turret and make your adjustments. There's a lot of different options on the market now as far as features for turrets. You can get locking turrets, you can get turrets with a zero stop, you can get turrets that have rev indicators that pop up to show you which revolution you're on as you go up in elevation. And there's a lot of different sizes of turrets. I generally like lower profile turrets on the scopes that I use, but as you can see, like this one has a fairly low profile, smaller turret. This gets a little bit on the bigger side for a turret, and then you have the kind of giant turrets on a lot of these imported scopes now. That's personal preference thing, but one of the major differences between these is how many mils per revolution are on the turret, and you have to kind of decide what you want to work with as far as that goes. So this SWFA and this Athlon scope are both 10 mil per revolution turrets, and the Arken here has 8 mils per revolution. So while the Arken has a larger scale on the turret because of its size and the fact that it's only 8 mils per revolution, it is something you have to keep in mind as you're dialing up, that when you go around one full revolution, now you're on 8 instead of 10. So you need to be able to keep track of that and count on the scale along with it. Once you get past the second revolution on this one, where you're at 16 mils, now it doesn't have any more numbers to help you keep track of your adjustments. So there is a little bit more involved in just keeping track of the number you're on as far as making sure you're on the right adjustment. So as far as the range of adjustment of your turrets goes, just something to be aware of is that when you're looking at an advertised range, say the manufacturer says you have a 20 mils of adjustment or 25 or 30, 36 mils, whatever, you're probably not going to be able to use that full range of adjustment for a couple different reasons. One of them is, even if you have a 20 MOA rail like this one, where you're going to have the front of the scope kind of angled downward toward the barrel, that's going to give you a little bit more range of use of your turrets, because it's going to allow you to go a little deeper into the turret for zeroing. But you're still going to have a range of adjustment below your zero that you're really not going to be able to use when you start shooting long range. So like this scope, for instance, has about 8 mils of adjustment left below zero just because of the way it's set up on the rifle. And so that total range that the scope has, I have to subtract 8 mils from that because I can't use that effectively for long range shooting. Another thing that kind of limits your ability to use the total amount of travel in your turret is how well the optical system works as you reach the end of your adjustment. So I have about 25 mils of total up adjustment in this turret, but once I get beyond about 20, the alignment inside the housing gets so bad in the optics that it starts to screw with the image coming through the scope. So it starts to look like there's some glare on it, and it starts to cloud up the image, and it changes where I have to position my eye behind the scope to be able to see it. So I really can only dial up to about 20 on this, and then I have to start using the reticle if I want to get range beyond what 20 mils will give me. So I think that covers pretty much everything I want to talk about in this video. Hopefully this is helpful information. I'll go over some setup stuff, and as far as how to focus your reticle and adjust parallax, things like that, adjust the scope in the rings for eye relief and set your gun up for yourself. I'll do that in another video, but for now that's going to be it. Thanks.